Hello and welcome everybody to our NFDI ToolTalk. Today the talk is hosted by DataPLANT, and it is my pleasure to welcome Dirk von Suchodoletz, the speaker of DataPLANT and head of the e-science group of the Computer Center of the University of Freiburg, where he is tasked with advancing research data management. And Jonathan Bauer, who is a developer in the Science Data Center Biodaten project, also at the Computer Center of the University of Freiburg. And together they will present us the status of DataPLANT services and their future ideas on that. So welcome on stage.
Thank you very much for your nice introduction of the two speakers. Unfortunately, I should give a warning notice. I just recovered from my COVID infection and might need to cough in between as not fully there yet where I hoped to be. Nevertheless, welcome to our presentation. We actually started the row of presentations in the Tool Talks seminar sessions a while ago. Then we were talking about a directly end-user facing aspect on our ontology advancing and metadata annotation system. Now we want to focus more on to the background services, on how we want to install and later on run that on the common NFDI infrastructure, which is meant then to support our fundamental plant researchers. We will give a short overview on the general infrastructure, which we achieved after 1.5 year plus into our project, share some general ideas on the versatile design of that infrastructure, so it is meant to be or to get installed in different sites, as we got requests, for instance, that for particular reasons it might necessary that some services need to run on premises where the data and the researchers are located in a certain project, for instance. My colleague will then talk about the initial selection of services we are hosting in that infrastructural framework and give ideas on how further services could get then added. We talk about the setup, configuration, and redeployable of individual services and all the designing principles behind that. All this is meant, like for the research data, we want to serve the reproducibility and transparency of the whole underlying infrastructure. We gave us internally pretty much 8 principles for our DataPLANT services, which should follow certain characteristics and fulfill a certain role in that. Just for references, I don't want to read them in long here. What we are doing, so to integrate a wider range of different services into a kind of a virtual unified entry point, is that we defined a proxy service, which is a traditional approach to allow a flexible operation of different services and especially make those scalable over different machines as well, is that we have such a stable entry point defined, which is getting installed on a redundant, highly available virtual machine. This could either be, for instance, VMware, ESX, ESXi, or whatever installation, Red Hat Enterprise virtualization, and so on. So the idea is that the computer center infrastructure takes care of that this service point should never die. There are various implementations available. The team was looking on different of those. Joey will talk a little bit about the selection criteria later on. And what was central to the selection criterion was that it's easy to manage, add further services, and make that in the future on automatically configurable, deployable, so that it's easy to add new services, test services, switch over between services, and so on. It might be required to have further proxies if they are on-premise services desired. That is was a try to give a graphical overview on how the infrastructure is designed. I already talked about the stable and static. Static in the sense that the users have a defined URL where to go to, and then this proxy service will then multiplex to the required service what the user is actually looking for. The proxy service will do the termination and for SSL TLS, for further security, and just hides in that way the actual services behind that entry. It can play further roles as well. For instance, do some regular service checking, testing, restarting if required. Depends, of course, on the service then behind. But we want to work in a direction that we can automate as much as possible. And that, of course, is the general idea of an entry point for our base for NFDI integration, so that we can take a single or a bunch of services and move them later on to other cloud infrastructures, for instance. That's why we see that mid-layer as dynamic and disposable in a sense that services can get respawned, reconfigured, and then run again, but for instance on other backend infrastructures. But of course, to make that happen, we need some persistent storage layer, so where all the data configuration and user data then is kept on. Which brings us then to a couple of redeployment steps. So pretty much every service needs to get fitted into a certain succession of steps. We hope to automate at some point to allow that operation later on. The idea is that we follow the infrastructure as a code principle. That is a principle introduced by our partner from partners from the Galaxy team. That is their operation model. All that config discovery of services is done via the proxy, the VM or container configuration, depending on what is required, or the networking setup, DNS naming, for instance, certificate handling, necessary routing. This might then get extended via some continuous integration infrastructure, so that we can separate production and development environments and test services before they actually are made production ready. A further challenge, of course, is the proper secret management. So for all those infrastructure components, they are building blocks required so that we can, on redeployment, for instance, have those necessary secrets ready, either, for instance, database keys, encryption keys, private part of the certificates and so on. On the other hand side, depending on the type of service, I mentioned a service we demonstrated here in that round a while ago, our ontology service. Depending on what type of service, different options exist on how this service can get properly made automatically redeployable. So parameters could be, of course, the networking requirements, bandwidths, what is actually required regarding the backend storage, if I could put it into a container, or if a full-fledged VM is required, and so on. And this list provides us the general assessment statements. So what needs to be done to host and integrate new services into our DataPLANT service stack. I already talked about that we might have different service environments depending on what the service is requiring to run properly, or at least to allow us, for instance, debugging in earlier stages, which is easier in a full-fledged VM than, for instance, compared to containers. Or bare metal. For bare metal, that actually might get required for rather specific requests if you have, for instance, GPUs which cannot properly get virtualized, or have some license restrictions on it, some instrumentation which has some controller card or whatever. So that option is possible, or at least taken in mind as well. In general, of course, we try to avoid the latter one. The idea for that infrastructure as code service base is that we have code base to properly redeploy all services, to have this as a safe space. Actually, our some neighboring not research educational institution here just got hit by some nasty encryption attack. So that is pretty much what we like to safeguard against. So if someone actually destroyed our infrastructure on how to reproduce it in a safe, fast, and secure way. That is what we have pretty much in mind. Not actually to have high available services. High availability often is rather complex and comes with a couple of caveats, and in the end you often see what you forgot about when you failed nevertheless. So for us, fast recovery is a way to go, and those are the building blocks we hope to have in place to reproduce our services on different locations. This is the point where I would like to hand over to my colleague, who will give an overview on the actual service stack.
1 second. Okay, is that working? Okay, perfect. So hello everybody. Thanks, Dirk, for the good intro. So after he introduced to the more generic concepts, I'm going to show you a bit of example of the DataPLANT services which are currently running in the infrastructure. So one of the main points is the entry proxy, which we are using Traefik for. It's our main entry point for all the NFDI for plants.org websites. Amongst the different choices there were, we choose that because it seems to have it has a very flexible configuration mechanisms through so-called providers. So it's not just the old file-based approach where you manually configure things, but you can also configure things using REST APIs or pulling files from web servers. And another nice feature of the framework is its closeness to container and Kubernetes, which we are aiming to focus on. So that's why one of the points why we choose Traefik as our entry proxy framework. Another really nice thing is the ACME support, which we built a couple of days ago, actually, with the DFN PKI. So you're not limited to just using Let's Encrypt, but you can actually configure the certificate generation with any ACME compatible provider, which is really really cool, because you don't need to actually create certificates manually and handle them each separately. And the consequence is that you can pretty much just spawn a new star NFDI for plants.org websites pretty much in seconds with a simple configuration file, and it automatically gets a certificate for it. Another nice feature is the fact that you can intercept HTTP return codes of the backend services, which we're using to create custom error pages, which is also nice for just simple branding reasons. And you can also, similarly with this so-called middlewares, create maintenance modes. So you can have a nice banner for the users that a certain service is being updated or something, independently if the service actually supports it or not from its side. So you can do it just for everything, basically. It comes with a nice web interface. So just to give you an idea of how it looks like, it's mostly for administration purposes, but you can see on the top left, for example, all the entry points, the ports open, services running. On the bottom, you can see the rules deciding how the proxy is deciding where to route traffic, and you can have more details on the right side with middlewares and certificates of TLS encryption status and stuff like that. So it's quite nice for administrative purposes. Just to quickly show you how simple such a configuration is for a single service. For example, on the left side, we have just a simple service forwarding it to an HTTP address, in this case, a local running on the same machine using a local hostname. And on the right side, you can see for an example of a of a middleware which adds a prefix for an external website. And that's pretty much all you need to do to actually create a NFDI for plants.org website, and through the TLS tag, it would automatically get the certificate as well. So that's simple with Traefik. So to actually get all the services on the in the one global state, the big question of authentication is obviously a big topic. So for that, we're using Keycloak, which is developed by Red Hat, which is an authentication proxy in simple words, which we're using for our DataPLANT services. Currently, we are requiring you to create an account on register.nfdiforplants.org, and afterwards you can link your account with external providers, for example, ORCID or the LS Life Science login, which is still a work in progress, but we had it was the former Elixir AI, which now merged with Life Science login, or became that, and that's work to be done. But the idea is just to have the possibility to log in with your external accounts on the DataPLANT landscape. And the nice thing is with Keycloak is that you can just aggregate all these services or all these features in one component, and you can expose that to your internal services via OpenID Connect, which most websites nowadays actually support. Just an example of a couple of services which we integrated. So obviously the GitLab is integrated with the Keycloak, so you can log in there with that without having to. And for us, just to make the point, it's important that you don't need to implement all these login features with different identity providers on each services, but you have your Keycloak, which is your main point, and everything else is just forwarding to Keycloak, so you don't have to do it on every services, which would be quite a hassle. So as I said, the GitLab, the R commander, which you probably heard in a previous talk for our of the DataPLANT consortia, which is also requiring GitLab tokens to do its work. So currently it's actually connected directly to the GitLab to get these tokens, but since, as Dirk said, we are planning to provide on-premises instances of GitLab, it makes sense to find a way using Keycloak to manage these diverse GitLab instances and to have just a central way to manage these tokens. Another newly added feature was the login in DataPLANT. So I'm actually not sure if it's currently live or not, but at least it's gonna be soonish. And there, the nice thing is, since we know that the people are coming from DataPLANT, I mean, the Galaxy people know that that the users come with a DataPLANT login. They are planning to grant them a larger quota by default for storage quota by default, which is a nice feature, but details are being worked on this part. I'm gonna come to that later. The data publication platform where we're using InvenioRDM also going to be connected to that. In particular, the connection between GitLab and the data publication platform is an interesting point. And another nice feature which we found out later was that Traefik supports with the middleware a possibility to plug in the authentication before any other website, basically. So you don't actually have to implement it directly in the website, but you can just enforce that the user need to authenticate using OpenID Connect before actually getting forwarded to the website. So that's also a nice feature to have from the Traefik. So as you saw earlier, there is a couple of monitoring features in Traefik, but we actually wanted to have a separate tool for that. So we are using Kuma for that. That's a simple live service status monitoring framework, which supports different protocols or different ways to probe the services for liveness. And especially the nice thing is it's pretty much stateless if you don't care about the actual events or the probing results, which you usually don't care because you just want to have a live status page. So that makes it easily deployable again with Docker and without having to actually do any backups or something aside from the configuration, obviously. And also the nice thing for administrators and users is you can set up notifications via emails, for example, or via, for example, Microsoft Teams, a channel where it gets messages get posted. So actually users get informed that there is some incident, and which is quite a nice thing to have. That's just currently an example. On the left side, you would see the regular status if everything is up and running, and on the right side you would see just a service maintenance notice, which you can just put on demand. Just briefly, another service which we actually needed to debug or to get a better understanding of bottlenecks or potential bottlenecks is Speedtest, which is currently deployed using LibreSpeed, which is an open source software for that, which is mainly here to test your connection to the DataPLANT proxy. And the idea is just, since we are talking about large data, download speed or upload speed is obviously a factor. So it makes sense to have also a tool where users can test it and just report the results. So that would be just an example of such a run, which the user can see. And on the bottom, you see an ID, which the users could then just give us, and we can just use that to further analyze what happened and correlate with timestamps of logging and try to figure out things. So another newly introduced tool is the virtual desktop environment for demonstration and training purposes. So the system is using the Bevilliers pool system, which is developed in Freiburg, which is a pool environment system based on virtual machines with teaching environments. And the idea there was to have a website for people to have a demonstration of the Swate and the Arc integration in a regular desktop environment without having to actually install the software themselves, so for courses and things like that. The website is on the bottom, so it's locked behind credentials, but if you have interest, just get in contact with us and we can give you that, so you can have it tested. And that's just an idea of how it looks like. So this is running in the browser. So it's based on a kind of remote desktop protocol, VNC to be exact. And the users can just log in this virtual machine and have an Excel program pre-configured using the Swate annotation tool, which you can see on the right side, which is just nice to give it a try before having to actually install the thing on your own machine. So another important part is the data publication. So here we are using InvenioRDM, or we're planning to use it in the coming days, actually. Which is an open source data publication platform made by CERN. In the context of the project, we aimed to be official partners. So as well, Freiburg and Tübingen are both official partners of the project, which is nice to be involved in the internal meetings and also to give feedback and be more in the loop of the development process. So one of the prominent features for us is the datasite integration to generate DOIs for published datasets. Yeah, as I said, there is currently a new version which has been updated, which we are currently in the progress of deploying, which brings data creation workflows, which is nice because it was also a big question in the DataPLANT meetings, how to design the publication workflows. And there in the new version, there is so-called communities where you can pretty much have a review process of a publication step and just make sure that the publication is in order before it's actually going live. And one of the open points is the publication trigger. So how do we want to actually start a publication process? So for those of you who know the Zenodo GitHub integration, there is something similar. So we developed a small prototype using CI in GitLab, which just checks on specific release tags and just create a publication draft on the Invenio platform. But that's just for experimenting purposes. We're still evaluating which makes the most sense and which is the better suited for the users. So yeah, I'm not going to go into details, but there's a lot of integrations which you can think of. One of the most prominent one is probably the the ORCID profile update. So we had different versions of how to make this possible. Now we're aiming to just simply use the DataSite auto update profile module. So basically, if a scientist connects its ORCID account with its DataSite account, each publication or each DOIS which is registered within DataSite just pushes automatically a new work activity in its ORCID profile, which the user has to accept. Which is quite nice for the scientist because it just does the publication on the platform and doesn't have to enter the same details on its ORCID page for work tracking. Another big point is the integration with libraries. So here it's more about tracking the work of the scientists and their publication for accounting purposes. And obviously the GitLab to just release, to just publish maybe a certain set or certain state of software or data using for ARCs in the HPC clusters or in gateways. There is a lot of possible integrations which we're evaluating with the InvenioRDM platform. So probably the most important service is the GitLab, which is our Arc management platform for the users. So as you probably heard, in earlier talks, the idea is to store arcs as repositories to have a history of the work being done there. The large files themselves are stored in Git LFS, and the plan is to use to create deployment in such a way that we can allow the GitLab to be run on premise, also with hopefully not too much work from the administrative people working there. The R commander you also heard of probably in previous talk, but it's just a simple tool to simplify the Git commands for non-techie user, I would say. So just, for example, to help with the initial creation of arcs, with the directory structures, the files which is supposed to be there, the tracking the LFS files, such things like that. And in the last 2 weeks or so, we also managed to implement the login using the DataPLANT keycloak. So upon using the R commander, the web browser of the system is opening and the user gets to log in. And with that, we are fetching a GitLab token. So the R commander can just directly has access to the API of the user without having the user to actually set up an SSH key or credentials or what have you. And that's from the user part of things. For us, for this talk, we are focusing more on the infrastructure as a code part. So for that, we are probably using an internal instance. And there we're mainly focusing on the CI part, so continuous integration, to just generate from our service recipes different packages depending on what we need. So either Docker containers or NPM modules or Terraform modules, and just to have this binary blobs ready to be deployed on the cloud. So yeah, this is just I'm just gonna skip that. It's just your basic CI pipeline, but the idea is at the end we want to have it published. We want to have the containers published in a registry. So GitLab actually comes with a Docker container registry, or DockerHub, or another self-hosted one. Doesn't really matter. And when we have those containers or those recipes built as containers, the question then is how to deploy them actually on the cloud. In our case currently, we are focusing on the cloud deployment. We are Kubernetes would be nice. We're working on that. It's not quite there yet. But anyway, the idea is just to use Terraform, a combination of Ansible and Terraform, because both can do similar things and sometimes not really, but they complement each other quite well. To just spawn generic VMs capable of running these Docker containers. So the idea is just to spawn a VM, install the Docker daemon, set up the whole configuration, and then just deploy the container on top of this VM. So the idea would be to have just an automatic deploy this container with this host name on the cloud. That's where we are currently aiming for. And yeah, just as a final picture, that's the big picture of all the services, which is actually just not even complete at this point. But as you can see, there's a lot of different kind of services and environments which we are running the services on. So on the left side, we have the proxy, which is our entry point. And you have on the right side, for example, our private cloud, or our cloud, which is where all the services are running in private networks. On the bottom, you have external websites. So there is quite a lot of flexibility there using the proxy, and so far it's been running quite nicely. And for the future, we have still quite a lot of challenges to tackle. So for one would be the registration of services in the proxy. How to automate this, because you don't want to do it manually, ideally. The concept I showed earlier, using one VM for one container, is kind of has an overhead. So that's also something which is not ideal for now, which is working nicely. But if you, for example, run multiple containers on the same VM, You have, again, the problem of network ports, which might overlap, but this also might be not an issue with the proxy. So that's something we're looking at. But as I said, as we have Kubernetes, hopefully a Kubernetes cluster coming soon or operable soon, that also might make sense, things different for the deployment part. So another big thing, as Dirk already said, secret management. There is the Vault project, which we're looking at to actually automatically get credentials for deployments. Also the topic of backup strategy, which we ideally want to have streamlined for all the different services and not have each one have specific needs. Obviously, each one has specific needs, but mostly streamlined if possible. And yeah, in the long term, the integration into the general NFDI services via this base for NFDI project. So that was it from my part. I thank you for your attention, and we are ready to take questions.
Yeah, thank you very much, Jonathan Bauer and Dirk von Suchodoletz, for that interesting insights. Especially for me, it was interesting to see how big your infrastructure already is and how many items are in there. I think that's quite a lot for the time DataPLANT existing. So yeah, we have some time for questions now. And for that, I'm going to end the live stream.